Okay. Hopefully you can all hear me with the microphone. I'm not used to using these. This presentation is really a look at where we've come from to the stage where we are with standardization at the moment, and why we've got so much diversity in the methods that we've currently got, and how we can move forward towards a single method and the challenges that are being presented to actually get a single method. So I've looked a little bit at the history of regulations across Europe. I've asked for feedback from, we have 3 national methods, the UK, German and Norwegian, so we've had some feedback from members from Germany and Norway on theirs. I've a lot more information about UK because I know UK in a little bit more detail. But from the national regulation side in the United Kingdom, we've got probably a lot of history going back on air quality problems and actual regulation of air quality, to the point that this isn't something new, even though we've looked at the slides just a few minutes ago from Marlon, which showed from the 1970s some massive improvements. The first regulation I found in the UK actually dates back to 1272, when King Edward I banned the burning of sea coal in London because of the really acrid and nasty smells and burning lungs that people were getting from the emissions. Sea coal was basically coal that was brought down from the north of England from coal seams that had been exposed by coastal erosion, and it was very tarry, bituminous coal. So that was the first regulation that we can find on air quality. We then had some information coming from John Evelyn, who was an advisor to King Charles I in 1661, who produced a booklet, Fumifugium, or the inconvenience of the air and smoke in London dissipated. And this actually gave some very useful information that they should relocate industry out of the city centres and start planting parks and trees to clean the air, which reflects in a lot of the cities now. They're not just concrete jungles anymore. They are quite urban parklands and avenues of trees that we see all across Europe, not just the UK. The one thing he got wrong was that he suggested that burning of wood was less damaging to your lungs than aromatic woods. What it was in those days, they could see black smoke and they could see a problem. What they didn't know was there was problems with invisible particulate that you can't see in the air, which is what we're now regulating down to. You can't see what comes out of the chimney at the emissions levels that are being tested for throughout Europe at the moment. And also in 1853, with the development of technology, the Marquis of Lansdowne brought in the Smoke Nuisance Abatement Metropolis Bill, which was basically that all furnaces should consume their own smoke. And this was after researching the development of down burning, so it wasn't just basic burning in furnaces and fireplaces anymore. They were requiring some technology. So it hasn't all advanced since 1970. There was work being done previous to that. We'll look at the national regulations of each of the 3 countries. And in the United Kingdom, before we go on to that, we suffered a devastating period in 1952 where over a lot of England was a weather inversion which held the pollution down closer to the ground level. That mixed with moisture and damp in the air, and it was a time when we had masses of coal burning. All domestic heating was mainly open coal fires or very early stoves, which were just a box with primary air. But we had the situation where the air became so polluted during these smogs that literally thousands of people were killed during the smogs. It was reported that even cows in the fields around London choked to death. The air was that bad. But that prompted us to introduce the Clean Air Act in 1956. And on the back of the Clean Air Act, which was legally binding across the UK, we introduced a requirement where you weren't allowed to emit dark smoke, so only white or light grey smoke. But it was still a visual situation. They were still talking about smoke you could see. There was emissions of grit and dust imposed on what could come out of appliances. Set up smoke control areas where there was tighter regulation on all combustion appliances, and it prompted the development of two standards in the UK, 3841 and 6434, which set out how you actually tested an appliance. And these were simply, after research of equipment, they chose as the primary method an electrostatic precipitator taken from the chemical industry, because it was known to capture very high capture efficiency and capture a lot of the pollutants coming from chemical plants. Some of the really nasty stuff was being used. It was sitting on top of a 4.5 metre chimney, and at the top of the chimney, because of the thermal mass and the air leakage through a typical ceramic British chimney, the temperature had dropped to around 80 or 90 degrees before it entered the precipitator. So it was capturing a good portion of the condensed hydrocarbons, the volatile organic compounds that are gases that don't condense until the temperature's low enough to form organic particles. And the efficiency of it was around 97 to 99% efficiency, so you know what's coming out the chimney is being caught, and it gives you a very good reflection on the appliances. The limits that are set in the UK reflect the fact that you're capturing all of the smoke, not just a sample of the smoke. And there's also an optical trace which tells you that when the smoke is being created, what parts of the combustion. So the optical trace gives you a graph of where within a combustion cycle the smoke is created. There is also a dilution tunnel in the UK that's used, that takes a partial sample of diluted air, and that the filter is, or the filter housing is maintained at 70 degrees, but the air is diluted down to colder than that through the dilution tunnel. It's isokinetic because you can have higher velocities in a dilution tunnel than a natural draft chimney, so you're sampling relative to the flow of the exhaust gas going through the chimney, and the results are fairly comparable between the two methods. So either will satisfy the UK smoke control requirements. The method, and it was said earlier, you've not just got the test equipment. The method that we use to test the appliances is they're tested under natural draft operation. They're tested with the fuel that the manufacturer declares the appliance to be used with. So if it's a logwood fuel, it's tested with logs, and it's tested at the maximum output that the manufacturer declares. So the fuel load that they say is the maximum for the output of the stove is tested. But we have a culture in the UK of trying to outdo our neighbours. We live in relatively modest housing because we've got an awful lot of population in a small area. So most of the houses are fairly small, but the culture is to have as big an appliance as you can for a nice big glass front on it, and something that looks better than your neighbour's got. So there's always nearly always an oversized appliance fitted, which means they're usually operated at a very low turn down position, and if you have your air too low for the fuel that's in the firebox, you create a lot of smoke. So the requirements under the Clean Air Act is that you have to test them at the physical minimum position that the air can be set for the stove. So you make sure at the minimum setting you've got enough air to maintain the clean combustion that the Clean Air Act calls for. If during the testing process you're fairly near the results, you then have to do an abuse test and put even more fuel in and do the tests. So you're overfiring the appliance as well. And to get some degree of repeatability, they actually do 5 tests of each of the firing conditions. So it's just not a one-off that was a freak result that gives you the results. There's some robustness behind the testing. And the other thing to consider in the UK is that the mean winter temperature is roughly 3.7, almost 4 degrees as an average temperature. So the heat loss from the houses, internal to external, is quite modest. You might be looking at 14 to 18 degrees temperature difference between inside and out, which plays a big bearing on how the appliances are used. So, as I say, I've got a fair bit on the UK. The other national measure methods, we've got Norway, and I've got to thank Morton from SINTEF for sending some information through on this. Their pollution control requirements were brought about after research, we think possibly in the 1980s, which was showing that in some areas of Norway, wood burning was attributable to around 65% of the total particulate PM10 emissions. And that prompted their Environment Agency to do a study of what test methods were available around the world that they could adopt in Norway for actually testing the appliances. And after a fairly involved study, they settled on the American test method. I can't remember the name of the American test method, but it was settled on that because it used a dilution tunnel, and they felt that the results showed the emissions that were coming out the chimney more realistically than other methods. They probably didn't look too deeply at the English one, which also tests what comes out of the chimney. But it was felt to give fairly real-life emissions of what comes out the chimney under those specific laboratory conditions, not the conditions that happen in reality. There was a change to the American standard, which was that the fuel load was changed slightly, whether it was the mass of fuel or the size of the cut logs, cut sections that were used within the firebox, changed a little bit from the American method. But the reason for modifying the fuel load was that in Norway you have much colder temperatures, so that your heat demand is much higher than in the UK. But the research prompted two standards, and that was the Norwegian standard 3085 and 3059. While I was looking for typical winter pictures of Norway on the internet, I stumbled across far too many pictures of semi-naked men rolling in snow outside saunas, but thought better not put any of those on the screen. Not yet, no. The test method used in Norway, as I say, is based on the American dilution tunnel. So the air comes out of a 4.5 metre tall chimney. It then gets diluted down, possibly is it a factor of 20 to 1 that you use? I'm not sure what the dilution factor is exactly, but it's, yeah, so there's a large dilution of ambient air going in with the flue gases, which promote the condensation of the volatile organic compounds. But they then take a sample isokinetically, because again you're at high volume, so the sample going into the sample probe is at the same velocity as the smoke and dilution air going through the dilution tunnel. So they know they're sampling realistically from what's in the tunnel. But they're sampling condensed hydrocarbons that have condensed to particulate, as well as the dry dust and grit that happens from the inorganic materials. As I said, the chimney is 4.5 metres high, but unlike the UK chimney, which sits from 4.5 metres from above the firebox, the Norwegian chimney sits 4.5 metres from the floor, so it can affect the draft, probably has slightly lower draft than the UK method. It's isokinetic, as I've mentioned. The results from the Norwegian test are expressed in grams per kilogram. So if you know how many grams or how many kilograms or tons of wood are being burnt in an area, you can get a rough idea of the emissions that you'd expect to get from that wood. And in England we use grams per hour, so again it's down, if you know how many and what size of stove is in an area, you've got a rough idea of the emissions that are going out to atmosphere. The method differs significantly from the other methods in as much that they use an engineered crib of spruce, which are cut sections 49 mil square, and those fill the firebox to an equivalence of 112 kilograms per cubic metre, so what a relative amount to that, which gives a very big surface area, and it uses spruce rather than hardwood, which again is a fast burning fuel, but it's one that's readily available in Norway. The testing is carried out at 4 burn rates, and as I've mentioned in Norway, the temperatures in Norway differ significantly to England and Central Europe, where you can have a temperature difference from inside to outside of possibly 60, 70 degrees in the extremes of winter, so the heat losses are far more, and the likelihood is that the people will overfire the appliances well above what they've been designed to do. So the crib takes account of that, but again it's down to the culture and the weather conditions in Norway that they use their appliances different to how appliances are used further south. As I say, the average temperature is -3 to -15 depending on where you are in Norway, and extremes can be -40 or -50 for prolonged periods, several days at a time. Not conditions I'd like to work in, or to live in rather. The appliances not using a representative fuel load that the manufacturer wants the appliance to be used with are then graded into 2 grades, and there's 4 tests at different fuel loads and outputs of the appliance, and you either get a grade 1 or a grade 2 to pass their requirements. And their emissions limits are set specifically around that firing pattern. And in Germany, again, their methodology was introduced to help local authorities manage their air quality plans. The BIMSCH V, and I'm not going to try and pronounce the German word, but their federal emission control regulation, first introduced in 1974. And again, looking for typical German winter scenes, it was a Christmas market, but the only one I could find Creative Commons came from Leeds in England rather than Germany. The BIMSCH was revised in 2010, introducing some step changes over the following few years. So it brought in a mandatory requirement to exchange old appliances. They found out from the testing that the new appliances, the newer technologies, are significantly cleaner than anything that's installed at the moment. So replacing the old appliances is the most obvious way of clearing up the air quality. And the emissions limits have also been tightened from the original limits. And the second phase, which is it introduced now, Frank?
1st of January 2015.
Yeah. So the current limits are equivalent to eco-design limits using the heated filter, PM method, and the OGC, and so forth. So it was the older appliances that need exchanging, not the new appliances which are made to the newer technologies that are the problem. The test method differs again significantly from the other 2 national methods, known by us as DIN+. I'm not sure whether that's the right name for the test method. I've not managed to find the actual test itself on any website, but it's basically a test that's carried out at the back of the appliance on the hot flue gas. So the filtering is done pretty much at the temperature of the flue gas coming out the appliance, and it's sampled at a continuous draft pressure of 12 pascals rather than natural draft. Again, I believe that's done to give more repeatable laboratory results rather than having different chimneys in different laboratories giving different draft conditions, which makes it very difficult then to do comparative testing between laboratories. It uses a gravimetric sampling with the velocity in the sample probe being higher than the velocity within the chimney. So it captures smoke, but not necessarily relative to what goes up the chimney, but the capturing then gets drawn through the filter rather than settling out in the suction probe itself. So there's some advantages with having the higher velocity within the suction probe. You're getting more on the filter than what settles out. It means cleaning is easier at the end of the day at the laboratory. But measurement is started 3 minutes after the fuel load is put into the firebox to give the fuel load chance for flame breakthrough and to start burning properly. And then it's continued for 30 minutes under steady state. And again, there's reasoning for this in the methods that happens in Germany. Particulates of condensed hydrocarbons, the volatile organic compounds that condense out when they cool or when they meet oxygen, or the primary ones at least that do in the local area, aren't caught and not considered. This is an appliance quality system that proves one appliance is better than another. So what they do is they use the organic gaseous compounds measurement to indicate that there will be volatile organic compounds and condensed particulate, and that limit is also set very low. So an appliance that meets the very low OGC limits, we're told, will pass the other national regulations as well, because it's the very low amount of volatiles that are going at the chimney. So if there's a very low amount of volatiles, then there's not that higher creation of condensed particulates. The measurement method, or the recording method of the particulate, is carried out in milligrams per metre cubed. So to be able to use the measurements, you need to be able to work out how many cubic metres are coming out of a chimney to work it back to the volume in an hour's use of a chimney, or what other methods are used for comparison purposes. So we've got 3 different methods that we need to compare against each other using different methods of recording the emissions. The method in Germany differs again. It's the partial cycle test, as I've just mentioned, but Germany is regulated much closer than other countries by their chimney sweeps. In England, we fit appliances that are generally oversized because we like the look of the appliances. In Germany, the chimney sweeps will carry out a heat loss calculation and insist that the correctly sized appliance is used, which then reflects in the fact that the appliance is probably going to be used at the right output. So that the chances of the sort of abuse of underfiring in England, or the need to overfiring in Norway, are much less. So you'll have an appliance being used nearer to the design specification of the appliance, simply from the culture in Germany. And as I say, there's big cultural and temperature differences that affect the standardisation. That means that the type testing that we've done under the construction products regulation for doing comparison of appliances means that the German particulate measurement shows that you're getting very clean appliances, and you can rank them in order of cleanest to dirtiest. What you can't do is say what's coming out of the chimney, but then there's always an uncertainty with all of the methods, but the numbers are always different between the tests. And the other advantage of the method is that the equipment is sufficiently simple and economical enough that manufacturers can have their own test rigs. So as appliances are becoming more technical, the manufacturers can basically do lots of tests themselves instead of having to pay premium prices for a notified laboratory to do development tests, which with the other methods it's quite expensive to set up a dilution tunnel in a factory laboratory, or an electrostatic precipitator operating at 10,000 volts isn't something that you want everybody playing with, because they are quite dangerous in the wrong hands. And again, the mean winter temperature in Germany, there aren't good details on the internet about that, but it's circa 3 degrees, so the heat loss isn't massive compared to the very northern hemisphere, or the very northern limits of the European area. So they're the national methods. So where are we with the standards at the moment? Those methods are reflected in CEN TS 15883, which is a specification that was being developed as a draft document to try and bring together the national methods. It was released in 2000, published in 2009, but voted through in 2008, and all it does is contain a description of the 3 methods. It doesn't give you how they are carried out in detail. That's contained within each country's national regulations. We've got the 16510 series of standards, which were in development. They've now been voted through with a positive vote. The new standards contain 2 parts. Part 1 is the general requirements, and Part 2 sections are each of the technologies, and Part 1 to 4, which covers inset appliances, room heaters, boilers and cookers, have passed the final vote, and they're in the stage of being finally edited before publication. They contain 2 PM methods. One is heated filter and the other is a dilution tunnel. The UK have effectively said, well, the electrostatic precipitator is only available in 1 laboratory. It gives equivalence to dilution tunnel. So as long as the dilution tunnel method is available that suits the UK, would be happy to go without imposing a ESP on the whole of Europe. But the requirement is there still for a dilution tunnel because that marries in with the volume of emissions that we record in the UK coming out of the chimney. And I believe Norway, though the test methods are different, I'm not sure whether that's acceptable to Norway or not, but given time and development work, it should be acceptable within the UK. The development of a single test method has been ongoing for quite some time. I think, and I've used some of Eric's slides from the last Working Group 5 meeting. It was first discussed in Working Group 5, which looks at the test methods, in 2002. There was some work done between 2002 and 2008 to try and develop a single method, and there was a method put forward by Christian Geigauf for a dilution tunnel method that they were hopeful would become a single European method, but it was voted out at the final stages of that process because it didn't reflect all of the different methods that are happening in Europe. That year they also finalised the technical specification, which gives the national methods that are being used at the moment. And then in 2016, March this year, we had a meeting to discuss how we can look at the eco-design wish, and really it is a manufacturer's wish as well to have a single method, because having to test 3 different emissions methods for a single appliance so you can sell it in different areas of Europe is an expense that is very difficult for a manufacturer to sustain. So a single method is wanted, but the meeting was called to discuss how we can go forward with that. There was some discussion of the existing national measurement methods and some discussion of the research programmes that have been going on in the background through the European Commission. There's been a project that's coming towards its final conclusions now called the Be Real project, which looks at an extended cycle of testing, quite an elaborate method, again using a heated filter, but what they're saying in that programme, it gives more robust data because it's done over lots of cycles. There's also a test, not a test method, but a sampling method programme called ENPME, which are looking at ways of more reliably sampling particulate coming out out of the appliance. One of the discussions that came about was, as a technical group looking at appliances, looking at the technical specification of how you make an appliance, should we be looking at what comes out of the chimney or how the appliance is built and made and what comes out of the appliance? And there was a good group of people within the group that wanted to restrict it to what comes out of the appliance. So that again reflects back on the heated filter methods, because you're doing it at the high temperatures out of the appliance and giving an indication with OGC that there will be condensed particulates. The ENPME test, because it's different and we haven't managed to get agreement on any of the national methods to go forward as a single method, it was felt that a new approach was really the only possibility to try and get an agreement. So the members went forward with promoting the ENPME as a means, as a basis of a start of how to sample, different to how we are at the moment, something that has the potential to be more repeatable from one type test to another, which is very important with regards to the development of the stove in the manufacturer's laboratories, then paying for a type test and then being market surveillance checked. If there's big variations in results from one test to another without any change to the appliance or fuel, then there's big problems when you put the product on the market and it becomes to market surveillance. So the conclusion was that we should investigate ENPME together with the method of firing the appliance and whether that could be adopted in Europe as a single method. A lot of research will be required. It isn't a finished project at the moment, so I can't see it being a very quick process to just go from the ENPME research straight into a test method, but that's one for the TC to work through. But of those, the difficulties that we're going to have to face, we've got the diversities of both weather and culture across Europe that need to be accounted for. On the slides we've seen that Norway needs to account for overfiring their appliances because of the phenomenally cold temperatures that they have for periods of time during the winter. Not the average, but the peak temperatures that their appliances under normal use just can't cope with, so they overload them with fuel. They try and get more heat out of them. And also that their emissions inventory is based around what comes out of the chimneys, so they need to have a test that can give them some reassurances that the numbers will match up with their emissions inventory. The mid-European countries and the UK, similar reasons. We've had our smogs that have killed thousands of people. We've got it right since then with regard to, other than the growth in diesel cars, the air quality has improved significantly through the Clean Air Act and the methods that we've got in the UK. And again, our emissions inventories were roughly based around some of the research done into the methods that we use in the UK. So the UK have made it clear that the full flow dilution tunnel needs to be able to correlate with any heated filter method, so that hopefully we could apply a factor to a heated filter method with the heated filter and OGC and know roughly how it will affect our emissions inventory. And we have to account for the fact in the UK that we oversize our appliances and use them turned right down, totally the opposite to Norway. Cultural change again, and we have slightly different weather conditions. And Germany, they regulate to make sure the right size appliance is fitted, so it's almost inevitable that most of them will be used in the manner that they were designed to be used. So they need to just compare appliances. They need to know which are the best. And they've already proven that the better appliances have had a massive impact on the emissions that come out of them. So is that approach acceptable across Europe? Do we need heated filter? Do we need dilution tunnel? They're still open for debate, but we're working through that in Working Group 5 to try and get the final result. And then we have to consider what happens with the southern European countries. In the regulatory committee, they made a stance that they actually only use their appliances for a couple of weeks of the year. They use relatively cheap appliances. Do they need to have to go from spending 200 or 300 euros on an appliance that's hardly used, that has very minimal impact on the overall air quality, to having to buy appliances that might be 2,000 or 3,000 euros to pass the minimum requirements of eco-design? And those arguments were put forward at the regulatory committee. So they have a stance where they want to have something far less robust, but the impact of burning an appliance moderately for a couple of weeks in the winter, opposed to using it for 10 or 12 hours a day every day of the week for 3 months or more, are significantly different. So really the goal for TC295 is to produce a single PM test method acceptable to regulators, manufacturers and environmentalists, and it has to really encompass some of the diversities that we've got across Europe and be able to give reassurances to everybody that the method is robust and accurate. And that method needs to be repeatable, because the manufacturers are no longer making simple appliances. They're quite complex. They need to have research laboratories of their own. So the equipment has got to be affordable for a moderately SME, small, medium-sized enterprise to be able to afford the equipment, to do the research, to make the appliances. It's got to be okay then to go from the manufacturer's laboratory and get repeatable results in the notified laboratories when they're doing the type tests. And it's got to be able to be used by the market surveillance authorities to make sure the appliances that are put on the market are of a robust enough nature and reflect the actual type test reports that were recorded. So we've been given a very difficult challenge, and really that's where my presentation ends. Thank you.